How is carbon stored in the soil? During photosynthesis, plants absorb CO2 and sunlight. They release oxygen and produce sugars, carbohydrates, and other long-chain molecules that are mostly made up of carbon atoms. Plants release up to 40% of these carbon-rich compounds into the soil as exudates to feed fungi and bacteria. They do so in order to promote growth in the populations of these beneficial organisms, as this will eventually result in a return of nutrients to the plant. Please watch the animation on nutrient cycling for further information. Fungi produce mushrooms on occasion, but that's just a small part of the way they grow. The majority of the fungus consists of hyphae, long, narrow tube-like structures that are made mostly of carbon. As a fungal hypha grows, it gets longer and branches off in different directions, looking for new food sources. Over time, its walls grow thicker and thicker, storing more and more carbon as the fungus continues to absorb exudates from the plant, and also organic matter in the soil. So how can this help in the battle against climate change? Well, the biggest single organism ever discovered on planet Earth was a fungus in Oregon that measured approximately the size of 1,665 football fields, and is somewhere between 2,000 and 8,000 years old. That's a lot of carbon being stored up for long periods of time. So you can think of this as a kind of carbon pump. Atmospheric carbon is absorbed by plants and pumped into the soil, where it is stored for hundreds of years by fungal hyphae. This process is known as soil carbon sequestration. How effective could soil carbon sequestration be in the struggle against climate change? Well, estimates vary, but here are some reasonably conservative numbers. Atmospheric carbon levels are currently just over 410 parts per million. That's totally off the charts when you look back over the last 450,000 years, as climate scientists have been able to do using ice core samples. This number has not been above 300 parts per million in that time. The red line on the graph is temperature change. As you can see, there has been a clear correlation between temperature change and atmospheric CO2 over the last 450,000 years. If the temperature continues to rise in accordance with current CO2 levels, then we're going to see some dramatic changes to our habitat. Just to put that in perspective, humans have only been on the planet for around 200,000 years, so we have never seen conditions like those currently being modeled by climate scientists. What is considered a safe level of atmospheric carbon? According to the United Nations IPCC, this is somewhere around 350 parts per million. That's around 60 ppm that need to be removed from the atmosphere, which equates to approximately 450 billion tons of CO2 equivalents. We're gonna need this number in just a minute, so let's put it over in the corner here. How much of this can be sequestered into the soil? The answer is, we don't know. What we do know, however, is that it is possible to sequester in excess of 10 tons per hectare per year, and possibly as much as 20 tons per hectare per year, as demonstrated by Dr. David Johnson at New Mexico State University, who has been successfully restoring the soil food web. Yes, this is cutting-edge research, but with more investment, this could possibly become achievable worldwide quite quickly. Humans manage approximately 5 billion hectares worldwide, so based on 20 tons per hectare per year, that equates to 100 billion tons per year. Total greenhouse gas emissions for the entire planet in 2019 were around 37 billion tons. About 50% of emissions get absorbed by natural processes, according to research by NOAA, leaving around 20 billion tons in the atmosphere. So if we did nothing else but regenerated the world's soils, we could potentially sequester about 80 billion tons per year. 450 billion tons divided by 80 billion tons per year means that we could theoretically get back to 350 parts per million, the safe level, within 6 years, just by regenerating the world's soils. Of course, we cannot do that overnight. Allowing time for global implementation, 10 to 15 years is a more realistic time frame. If you factor in reductions in greenhouse gas emissions, the picture begins to look far more optimistic. The bottom line is that this could be a big piece of the puzzle when it comes to fighting climate change. For more information about the numerous benefits of the soil food web and how you can get involved, visit soilfoodweb.com.